All right, number 4 says find increasing, decreasing intervals and any local extrema of the following function. So remember, extreme values are where your function reaches a relative min or relative max, or in this case, local min or local max. So it's where your curve changes direction. To do this using calculus, and to also find increase and decrease in intervals using calculus, we want to take the first derivative and use the first derivative test. So this derivative shouldn't be too bad. To take each of these terms is, you can just use the power rule for each of these terms. And so the power rule, f prime of x, remember, to take the derivative of x to the 4th power, that's going to be, you bring the 4 down, so it'll be 4x decrease the power by 1, so to the 3rd power. And now go to the second term, negative 8x to the 3rd is going to be minus 3 times 8 is 24, decrease the power by 1, so x squared. And then finally, that last term, plus 32x. And so to find increase and decrease in intervals and local extreme values, what we want to do is set this first derivative equal to 0, because remember, that's where we have horizontal tangent lines, and so that's where we might have a change in direction to the graph of f of x. So let's set this equal to 0. Notice each of these 3 terms in the derivative has a common factor of 4x, so let's factor out 4x, and then from there we'll have x squared. 24 divided by 4 is 6, so that's going to be a minus 6x, and then 32x divided by 4x is plus 8. All right, we'll continue to factor. So 2 numbers that multiply to be positive 8 and add to be negative 6 would be x minus 4, x minus 2. So our critical numbers would be x equals 0, x equals 2, and x equals 4. And so what we want to do with those critical numbers is take a number line, break up the number line into intervals using those critical numbers, make sure they're in order. And then what I like to do is take my derivative, the factored version of my derivative, and write those factors way over here. So 4x, x minus 4, and x minus 2. And then right below those, I'm going to write the word result. And then at each of these critical numbers, I'm going to make dashed lines to indicate that I have 4 intervals that I'm testing. All right, in each of these intervals, I want to choose a number. So in this first interval from negative infinity to 0, any number you want in that interval. So let's say negative 5. All right, pick a number between 0 and 2. Let's pick 1, 2.5. And then finally, way over here, let's say 10. All right, and the idea, each of those orange numbers, plug them into those factors of the derivative and see what sign it makes those, positive or negative. The number doesn't matter in this. We're just testing to see, does it make those factors positive or negative? So if I take negative 5 and plug it into 4x, that's negative 20 exactly, but we just care that it's negative. Negative 5 minus 4 is negative. Negative 5 minus 2 is negative. And now think, these are factors, so if I take 3 negatives and multiply them together, that will give me a negative result. Now do the same thing with all the other orange numbers. So take 1, plug it into each of these. So you have positive there, negative, negative. Now we have an even number of negatives being multiplied together. So 2 negatives multiplied together is a positive times another positive, give me a positive result. 2.5, let's plug that in. This would be positive, negative, positive, and therefore a positive times a positive is going to be a negative result. And then finally 10 would make all of these positive, which results in a positive. All right, so what does this chart tell us? Anywhere we have a negative result, so here and here, that tells me f of x is decreasing. And then f of x is increasing, where we have positive results. To find local extreme values, what we want to do is take each of those points where we change direction, which is at each of our critical numbers. Think about if my function were decreasing here and then increasing on the other side of 0, this would be a minimum, relative minimum, or local minimum. There'd be a local max here when x is 2 and another local min. So let's find those values. All right, there we go. And so we'll just interpret those as, let's get orange. Actually, let's get red. Let's see here. Now remember, the function value is the actual local minimum value or local maximum value. So this coordinate here, 216. 2 is the x value. That's where the local maximum of 16 occurs. So the x value tells you where the maximum or minimum occurs. The function value or the y value actually is that value.